we've discussed what makes up a complete SD access solution. So now let's take a look at a common way we might see this implemented in an enterprise topology. You can see at the very bottom, we have our end user devices, both wired and wireless clients here. The first piece of the SD access implementation that we'll examine are called the fabric edge nodes. This is the layer that provides user access through wired or wireless connections. Not only does this provide a connection point, but this also is where identity and authentication for users takes place. This is where Cisco TrustSec and Cisco ISE are leveraged to enforce security policies and to place users into the appropriate access groups within the network. So these devices sit on the edge of the SD access fabric, as you can see here, and they provide users a place to connect into the network. We also have what are referred to as fabric intermediate nodes, and there could be any number of these nodes. These are simply the internal routers or switches that are part of the underlying physical structure. They have no role in SD access other than providing the underlay services using protocols such as OSPF or EIGRP, for example. Remember that the underlay network isn't dependent on any specific protocol. It can be a mixture of all kinds of protocols, and that can be wired or wireless as well. Then we have what's called the fabric control plane node. Remember from our previous video that the control plane uses Lisp encapsulation for node mapping. Lisp contains two namespaces for each node, an endpoint identifier or EID and a routing locator or RLOC. This particular node would essentially be a Lisp server, and it would contain a database that would be used to resolve these EIDs to RLOCs in order to map the nodes within the network. So the fabric edge nodes that we looked at earlier would provide information from our connected clients back to the fabric control plane node so that they could create and update these mappings. Now, this Lisp server would also resolve lookups from those nodes. It's important to note that you'll want to choose a fairly robust device to act as a fabric control plane node, because this is going to contain all of the fabric mappings. So just be aware that there's some fairly stringent hardware and software requirements when you choose this particular node. You want to choose a fairly robust device. And we also have a fabric border node. These are essentially Lisp proxy tunnel routers that allow for external layer 3 connectivity back into the SD access fabric, so they can communicate policy and identity information between separate domains, whether that's a remote office or maybe a data center. There are three types of fabric border nodes you want to know about. There are internal border, default border, and anywhere border. Internal border nodes are also referred to as rest of company nodes. They connect only to known areas of the organization. These could be a local data center, a wireless LAN controller, or a firewall, for example. Default border nodes are also called outside border nodes. They connect only to unknown external networks, such as the public internet or a public cloud. This will be configured with a default route pointing to the outside world. And anywhere borders combine internal and default border nodes, offering connectivity both to the inside of the organization and outside to the public internet. We can see the fabric control plane and fabric border nodes here connected out to our server room. This, of course, will contain our Cisco DNA Center and Cisco Identity Services Engine appliances. And we also see a wireless LAN controller here. So this requires that you have fabric capable wireless LAN components, by the way. We do want to mention that. Both the access points and the wireless LAN controllers should be fabric capable. One difference to point out here, as opposed to traditional wireless deployment that we've discussed already, it's very common to see a centralized topology in the enterprise. This means that the wireless LAN controller, when it's traditionally placed, is centrally connected to the network infrastructure and has access points dispersed throughout the physical buildings. And when we have that traditional model, all of the control plane and the data plane traffic from the wireless clients is moved from the access point, and it's tunneled through the wireless LAN control using CAPWAP tunnels. We've talked about those already as well. And that allows the wireless LAN controller to handle everything, both the control plane and the data plane traffic. Now, the difference in that traditional wireless and SD access wireless, we know that with SD access, the data plane is distributed using VXLAN. You'll recall that from our previous video. So in an SD access wireless deployment, a Fabric AP would establish a VXLAN tunnel with a Fabric edge node, and it would do that rather than establishing a CAPWAP tunnel with the wireless LAN controller. Now, it still does have a CAPWAP communication going on. We'll talk about that in just a second, but the VXLAN tunnel that's created here is used to carry data from the access point back to the SD access fabric, where the overlay network can take care of directing the traffic anywhere it's needed. So this is a much more efficient and scalable type of topology for wireless, because the traffic doesn't always have to be carried all the way back to the wireless LAN controller in this model. For control plane traffic, we see that this is still carried back to the wireless LAN controller using CAPWAP, but this time it's CAPWAP encapsulated inside of a VXLAN tunnel. So that's still handled by the overlay network, and you still get the advantage of using the SD access fabric to carry the control plane traffic back to the controller. And of course, this is all managed, orchestrated, and monitored by Cisco DNA Center. This provides a GUI interface where we can create policies and subdivide our network into virtual instances. And we have an automated control platform that's going to assist us with configuration and device provisioning. So that's a look at how SD access is commonly implemented in an enterprise environment and how it interacts with traditional physical network devices to help us improve our networks and to make management of the networks much easier.